Hello everyone. So in today's lecture, we'll be actually working with a joystick, which is our external peripheral. So we all know what a joystick is, like most of us do who have played any video games. So basically, joystick is something that you can control a movement of a character in a video game with. So I'll be showing you an image on the screen right now, and maybe you'll have a better example like this. So basically, the joystick can be thought of as a Cartesian plane which has x and y coordinates. And as you move the joystick around with your thumb, the coordinates change. So the way we get these coordinates from the joystick is using analog read function. So basically, the joystick that we'll be using has ports. So the two of them are for power, which are ground and 5 volt. Then we have VRX and VRY, which are actually used to store the value of the coordinates. So the VRX is basically used to store the value of the x coordinate, and VRY is used to store the value of y coordinate. So basically what is happening here, VRX will be giving an analog signal to the Arduino board, which will convert it into digital, and we can get those values between 0 and 1023. So basically that will be our coordinate, x coordinate, if we connect it to VRX, and similarly we'll get the y coordinate using the VRY. Over here I have a graph which shows that 497, 531 is the origin of this joystick. So as you can see here, we have for our first quadrant x values between 497 and 1023 and y values between 0 and 531. Moreover, in our second quadrant we have our x values between 0 and 497 and y values between 0 and 531. In our third quadrant we have x values between 0 and 497 and y values between 531 and 1023. In our fourth and last quadrant we have x values between 497 and 1023 and y values between 531 and 1023. So the objective of our program that we're going to write is that as we move the joysticks around in these 4 coordinates, different LEDs should turn on of different color. So as I make the circuit diagram of this program and also talk about more about this joystick interfacing, the program and the interfacing will get clearer. There is also a master switch, which is basically a digital switch on the joystick, which basically sends a digital signal to the Arduino board, and we can use that to turn all the LEDs on at once. So here we are in Fritzing, and let's actually create a circuit diagram. So let me search for our main component, that is the Arduino, and bring it in to our workspace. So after doing so, I'll be searching for our next component, that is the joystick. So this is the joystick that we're looking for, the thumb joystick. And as you can see, it has 5 ports: ground, 5 volt, VRX, VRY, and the SW, which is basically the digital switch that I was talking about. We'll also take a breadboard to actually make the connections for the 4 LEDs that we are going to light with the help of moving this joystick. So I went ahead and created the whole joystick diagram. So I've also used different colors for the LED, and let me just tell you about the circuit diagram as a whole. So we've connected the digital switch to our pin number 2 on the Arduino board. We have also connected these 4 LEDs to the pins 4, 5, 6, 7 on the Arduino, along with 220 ohm resistors and different colors for the LEDs. We have also connected 5 volt and ground to our joystick, and we have used A0 and A1 for our VRX and VRY. So they'll be responsible for actually getting all the data of the Cartesian coordinates that we just discussed of the joystick, and as we move the joystick around in the specific coordinates, the LEDs will turn on. So let's actually write the code now and see what that looks like. So here we are in the Arduino IDE, where we will be writing this code. So let's get started. So I'll be also showing you the circuit diagram side by side so that you can have a better understanding as we write this code. I understand that this code will be long and the circuit diagram itself was quite complicated, and I encourage you to actually rewatch the explanation of the circuit diagram and actually make sense by yourself by connecting the wires. So first of all, we will be creating three variables. The first variable will be int x, where we will be storing our x coordinate of the joystick. Then we will be creating int y, where we will be storing our y coordinate. We will also be creating another variable int a, which will have the function of actually storing the value of the master switch, basically the digital switch, the digital value that we will be getting on the Arduino board. With that in mind, first of all, let's actually declare the digital pin 2 of the Arduino board as input, because that is where our digital switch is connected. So pin mode 2 is our input, and we are in semicolon now. And so let's actually configure all the LEDs, the external LEDs that we have attached. So we've attached them to the pins 4, 5, 6 and 7. So let's write pin mode 4 as output. And let me just copy paste the statement and do so for the rest of the pins as well. So 4, 5, 6, 7. We also want that they are off in the initial stage, and that is why we will be writing digital write 4 as low. So I will be copying and pasting the statement and making the necessary adjustments for all the LEDs to be off in the initial stage. We're also going to initialize serial communication so that we can see the coordinates of the joystick in the serial monitor. So serial dot begin 9600. So with that out of the way, we can actually move to our code. So first of all, we want to actually get the values of x and y from our joystick. So we'll be writing x is equal to analog read. We'll be using the analog read function here, writing a0 where the x is connected. Next, we will be writing y is equal to analog read a1 where y has been connected. Moving on, we will be writing a is equal to digital read 2 where we've connected our master switch. We also want to print them, and in a really systematic manner. So the way we'll be doing that, we'll be writing serial.print first of all the x coordinates. Then we'll be actually giving it a tab space. So we'll be writing serial.print \t in inverted commas. So basically what this will do is that we give some space between x and our next variable to make the code to make the data look much cleaner. So I'll be just copying this statement down, writing y over here. Similarly, we'll be giving a \t to give a tab space again. And finally, we'll be printing a, and at this point of time, we'll be actually changing the line, so we'll be printing L over here. Now, let's actually move to the main code. So, you must be wondering why I have chosen 497 and 531 as the center. I have not chosen them. It's because when I used my joystick and plugged it into my Arduino Uno and see what were the coordinates of the origin, which means that when I was not touching the joystick at all, what was the stationary state, what was the stationary coordinate of the joystick at that point of time, and that came out to be 497,531. So that is how I've tailored my code. But just in case it is different for your joystick, feel free to change it a bit, but I assure you that it will be close to 500. So now let's actually write the main code. So we want that whenever the joystick is in the first quadrant, the red key gets on. So according to the circuit diagram, and the Cartesian plane that we just saw, every time the joystick is in the first quadrant, we want that the red LED turns on. And in order to do that, the joystick should have the x coordinates ranging between 497 and 1023, and the y coordinates ranging from 0 to 531. So let's code that. So how will that look like? So if using an if statement, x is basically greater than 497, and so the operator for AND is y is less than 531, which means it is in the range of 0 to 531. If this statement is satisfied, what we want is the red LED to turn on, which is connected to pin number 4. And at the same time, we want that all the other LEDs turn off. So we'll be just copying this code right here, pasting it in order to turn all the other LEDs off. Next, we want that every time our joystick is in the second quadrant, which means that the x value is between 0 and 497 and the y value is between 0 and 531. In that case, we want that our blue LED turns on, and our blue LED has been connected to the pin number 5 on the Arduino. So in order to do that, we'll be writing if x is less than 497 and y is actually less than 531, which means that it is in the second quadrant. We want that the blue LED turns on, and the blue LED has been connected to the pin number 5 in the Arduino Uno. So let's just copy this chunk of code, and instead of turning 4y, we will turn 5y and 4 2. So I believe you get the idea that we're going for right now. So I would encourage you to pause this video and try how to write the rest of this program. So now we're just making the necessary adjustments. So our orange LED has been connected to the pin number 6 on the Arduino Uno, and we want that every time the joystick is in the third quadrant, we turn the orange LED on. So the third quadrant means that the x value is between 0 and 497 and the y value is between 531 and 1023. So that is what I'll be doing here. So the x value looks good. However, we want to change the y value and make it greater than 531. So the reason that we're not writing 0 and 1023 as the limits, because that is pretty much understood and we will not be getting any value larger than that. So that's pretty much okay. And in this case, we'll be turning 6 high and 5 low. So we come to our last case, and we'll be turning on the yellow LED now, which is connected to pin 7 of the Arduino Uno. And every time the joystick is in the fourth quadrant, we want that the yellow LED turns on. And in order to do that, our code will look somewhat like this. So first of all, the fourth quadrant, which means that x is greater than 497. It lies between 497 and 1023. At the same time, y lies between 531 and 1023. And we want that our yellow LED turns on, which is connected to pin number 7, and we make 6 as well. So moving on. So this looks great. One thing that we missed a few semicolons, and I'd just like to complete them. So this pretty much looks good. So one more function that we like to add is that every time the master switch is pressed, the digital switch that is connected to pin number 2 on the Arduino Uno, all the lights turn on. So in order to do that, we'll be writing an if statement. If A is equal to 1, we want to carry out digital write 4 as I. We'll be copying this statement and doing so for all the other LEDs. So we make this as 5, 6, 7. This looks good. With this, we come to the end of our master switch as well. And I would safely say that our code is well written and it should be working.